Hello, this is Ting Ting, and welcome to my final project presentation. So this is the course for Machine Learning Foundations for Product Manager. And this final course project, we want to touch base on some machine learning hands-on experience. So let's first start with the project background. So in this project, we are asked to build a model to predict the electrical energy output of a combined cycle power plant, which uses a combination of gas turbines, steam turbines, and heat recovery steam generators to generate power. And we can see that we have 9,568 observations in our data set. And this data set contains 5 different variables. We have the temperature, we have the ambient pressure, we have the relative humidity, exhaust vacuum, and finally our net hourly electrical energy output. So the energy output will be our target variable to predict. So in order to do this machine learning project, I use Google Auto ML to help me run the model. So I first import the data set and let the Google Auto ML to help me run model with all the variables. And this is the result I got. So I choose to optimize for mean absolute error because so that we can view extreme value as outliers with less impact on the model. I assume that there might be some outlier values, which we probably don't want to include in the model. That's why I choose optimize for MAE. And then all the other model I run, I also choose optimize for MAE. So here. And this is the result I got. So it only gives me feature importance, but from the evaluation result, we can see that first of all, this is regression model is going to be the preferred approach, and the variable AT and V, which is the ambient pressure and vacuum, have the most impact on our target variable, the energy output. So with this result in mind, I choose to use different values to run the regression model. So the other method I tried is I only use AT and V to predict our energy output. And this is the evaluation result I got. We can see that for mean absolute error, we didn't have much difference. But for the other 3, we all have a bigger improvement. For example, for R square, we have 0.961, which is much higher, a bit higher than the previous general model. And the other 2 also have a major improvement. So looks like we might get a better model with only using 2 variables. So I continue my analysis by doing predicted value versus actual value. So I want to compare these 2 models. So we can see that if I put the predicted value and the actual energy output value together, on the left side, this is model with 2 variables only, and the right side we have model with all 4 variables. We can see that from this graph, we didn't really see a difference. It looks pretty similar, right? Like there probably won't be much bigger difference. So I take a closer look by looking at the predicted absolute error. So from this graph here, we can see clearly that if we are looking at the absolute error from our prediction, the model on the left side, which is using only 2 major variables to predict, actually have a slightly better performance than the one on the right. So with that, I conclude that, first of all, we use regression model to predict the energy output. And second of all, predict using only 2 major variables has a better performance than using all 4 variables. And I also validated the model using a 10% test data set.